Hello, everyone. The topic of my presentation is an improving approach from DOM-based web test suite repair. It includes 5 parts: background and motivation, our approach, web test suite repair, empirical evaluation, results, and the future work. For the background and motivation, we give an example of web application Joomla. It's from release 3.6 to release 3.7. For the sake of clarity, we say it release 1 and release 2. It includes 3 pages, and developers add fields and field group in the third page. This is an example of web application evolution. And this is the test case in 2 releases of Joomla. This test case is written for release 1. Each action corresponds to the tag from tag 1 to tag 7. It inputs username, input password, click login button, click articles, click featured articles, input the search content, click search button. However, with the web application evolution, the selectors are changed. So the test cases are broken. To solve these problems, we propose web test suite repair. This is the architecture of web test suite repair. We run the test cases on release 1 to generate test suite graph of release 1, and we also run the same test cases on release 2 to generate test suite graph of release 2. And then we compare these 2 models to repair broken test cases. The test suite graph is 5-tuple structure. S is a test suite that consists of a set of test cases representing all tests. U is a set of URLs representing all web pages of test cases. A is a set of actions representing object events. L is a set of links that may follow edges between different actions. C is a set of candidate actions after each test action. After we generate these 2 models, we compare them to repair the broken actions by using the candidate actions. Then we do empirical evaluation. There are 3 research questions. First, is it possible to generate test suite graphs for 2 different releases of a web application? Second, is it possible to automatically repair test cases for web applications by comparing test suite graphs? Third, how effective is our test suite evolution method? We choose 3 real web applications: Joomla, Moodle, and Dollybar. There are many releases for each web application. So we randomly choose 2 releases of each web application. Table 2 shows that we can generate test suite graphs of web application. the test suite URL, action, links, and we also record the execute time. Let's take Joomla as example. For release 1 and release 2, we generate 2 models. For release 2, there are 96 test suites, and there are 38 broken test suites. And we will try to repair the broken tests in the following steps. For the times it takes to generate the test suite graphs, we can see that the cost of time spent to build test suite graphs is related to the number of actions, and they have a positive linear correlation. And then we compare our approach with Water. Water is an existing tool that proposed in 2011. We use the same web application and same test cases. And then we compare the repair ratio and the execute time. From the table 3, we can see that our repair ratio is a little better than Water, and the execute time is almost the same. So we can see that our approach is effective to repair test case for web application. For another findings, we can know that as the number of broken actions in each test case increase, the repair ratio will decrease. For example, if there is only one broken action in a test case, the repair ratio is high. If there are 4 broken actions in a test case, or more than 4 broken actions in a test case, the repair ratio is low, or the test cases can't be repaired. For the future works, first, we experiment our approach to the web applications with bugs to study how do bugs affect the usefulness of this test repair approach. This is because we did not consider the bugs' influence in our approach. And second, collect user feedbacks on our technique to make our approach better for web test repair. Second, update our algorithm to improve the efficiency. Okay, thanks.